Okay, so for the recording, welcome to the lecture about MicroPython and the RP240 microprocessor. And so let's start. Okay, this is the abstract. I was asked to write an abstract, so I will talk about I will talk about MicroPython, about some microcontroller boards, including those based on the Raspberry Pi Foundation RP240 and the RP2350. I will also talk about another chip which is called ESP32, and both of these run MicroPython very well. And I'll give some introduction, which is enough for actually running the demonstrations on the hardware. So let's talk about MicroPython. It's a subset, though it is surprisingly large, controlling the size of the chips it's running on, and it's supported by lots of microcontrollers. Those who are not included in the types of microcontrollers are the Arduino, like the classical Arduino controllers. They don't support MicroPython. So the CPUs I will talk about are the RP2040, and there was a new revision released a few months ago, which is called the RP2350, and they are, as I said before, they are produced by the Raspberry Pi Foundation. So there is a distinction between what is called micro controllers and what are CPUs, though the border is quite fuzzy and has nothing to do with size. As an example, I brought this along, which is about the same size of some of the boards, and this is the Raspberry Pi. This is a real computer. This is a real computer with a CPU, whereas these boards here, you can see the board which is right there. This is a microcontroller, which is also produced by MicroPython. Sorry? No, this is a board called the RP20. Yeah, it's the Pico. It's the Pico board, which is produced by the Raspberry Pi Foundation. So it's not according to the size of the board, but it is about the capabilities and how the processor is produced in terms of memory management and so on. And again, MicroPython is also running on the ESP series of micro processors. And it's actually an interesting story. The ESP8266, which was the first generation. I think I have it here somewhere. If I brought it along. Well, it's here actually. Let's see. Yeah, so this is the processor and sitting on a small daughter card, and which is plugged into a serial controller. This was released by the SBRIF. It's a Chinese company, and in the beginning it was produced just to be a Wi-Fi interface for the Arduino. And if some hackers eventually figured out how to write code on the chip itself, and eventually it was also found that it is strong enough to run MicroPython. So this is probably the cheapest board you can buy, which runs MicroPython, which costs about 5 shekel, and you can get it from the AliExpress.
And it also has Bluetooth, right?
Its big brother, the ESP32, also has Bluetooth. Let's see. Hold on, my mouse is acting strange. Let me fix the mouse.
So just to be clear, none of these are full-blown computers like the Raspberry Pi. These are all microcontrollers.
That's correct.
Like the Arduino.
Yeah. But again, the border is fuzzy, especially the latest version, the RP2350. it actually includes two CPUs on the chip, one in which is RISC-V, which is actually a real computer, but it's complicated. So we're not going to get into that. So today I'm talking about computers that run a single program, which is MicroPython. So this is similar to how the Arduino is running one program, because in the Arduino you're using the Arduino IDE, and you're writing your program, and then you're burning it, you're uploading it to the chip, and that's what it's running. So this is one of the advantages of MicroPython, because you only need once to upload MicroPython to the chip, and from there on you're actually in a Python environment. So we'll see that.
Well, for the people in the audience who don't know what microcontrollers are, could you briefly explain what they are and what's their purpose?
Well, microcontrollers is one type of a computer. So computers, they're not something which necessarily look like Windows, which has a screen and a keyboard. So the distinction, I think the best way of describing it is to describe the distinction between a real computer and a microcontroller. And the distinction is that microcontrollers run a single program. It might have several cores, but doesn't run a real operating system. It only runs the program that you put on there. So it's much, much simpler, because a real operating system has memory management and interrupts and lots and lots of things happen in the background. Now, the advantage of microcontrollers is that you have a guaranteed time in terms of instructions, whereas on the CPU, you may get interrupts. And Windows, for example, is known for that you can not get anything on Windows running in terms of real time, which is promised to run more accurately than a few hundred milliseconds. Yes?
So you can't run you can't run a subprocess on MicroPython, right?
You can't run a subprocess, but you can run async I/O, if you know what that is, which is not. It's also a way of multitasking, but it's a synchronous way of multitasking. You don't have background threads. You don't have any threads. You only have a single program. So, a few words about the RP2040. I don't have a pen. I realize I brought everything except for something to point with. That's okay. I can point with the. Okay. Thanks. Okay. Yep. I just wanted something to point with. So this is the controller. It's what's nice about it. Its documentation is amazingly good, which is interesting and compared to the ESP 8266 and ESP32. When they came out, they only had documentation in Chinese, and it was really a question of reverse engineering. So the processor, it's an ARM Cortex M0. And the clock goes up to 133 megahertz. So it has 264 kilobytes of on-chip memory, and it has lots of ways of talking to other chips. And these are kind of standard electronics protocols, UART, SPI, and I2C. And also has PWM channels. And okay, let's skip this. But again, it's programmable in the C and the C++, Lua, and MicroPython, and probably a few other environments as well, if you really want to. And the price is about $5, and you can get this chip in Israel for about 25 shekel. There's a nice company called Pytel that sells this. They also sold this nice board here, which I'll be using for the demonstrations. It lacks Wi-Fi though. However, there are boards that combine the RP2040 chip together with a Wi-Fi controller. So then you get Wi-Fi on the chip. So before we started with the demonstration, let's go into some basic electronics. So this is for programmers who have not touched things ever. So how you turn on a LED? So a LED is like a small light, and to turn it on, you have to put voltage through it. However, if you connect it on one side to the power supply and on the other side to the ground, you will burn it. You need a resistor in the middle to limit the current. So let's do that. So, oh, wait a minute. Let's wait for the next slide. The second thing I want to talk about in terms of electronics is something called a breadboard. Breadboards are nice for prototyping. It has holes where you have strips of connectors. So if you want to build a circuit, like the circuit which I showed on a previous slide, you can build it on the breadboard. So let's try it here. So here I now have this prototype board is connected, and it exports some of the pins from the chip into these connectors. We can actually connect it directly. So it's a bit difficult to see, but if I take this here and connect it up there, so now I produce the circuit. So the current goes from the plus 3.3 volts and goes into this strip, this vertical strip right there. It goes through the LED, through the resistor, and then goes to the ground and goes back. So this is really the hello world of electronics, how to turn on a LED. Now in electronics, you typically don't turn on a LED manually, but you might do it a kilohertz, 1,000 times a second, or 1,000,000 times a second, depending on what the kind of protocol you're talking. Okay, so let's talk about the programming of the RP2040, which is you have to copy the MicroPython onto it. And the way it works, and I will, because of lack of time, I will not demonstrate it right now, but you have a button here, which is called the boot cell. And if you press this button and you, at the same time, connect it to power, then the the Pico device will appear as another drive under the operating system. Okay, so if you have your file manager, you can see what drives you have connected. If I do that, then the chip will appear as another drive, and then you take your MicroPython program or any other program if you want to program in C++, and you just copy it over to the chip. Once the copying has finished, the chip reboots, and from then on you're running the MicroPython on the chip. Okay, now other microcontrollers have different ways of uploading their firmware. For example, the ESP32. Let's show this is the ESP8266. So here's a nice device which has an ESP32 inside of it. And for this one, you need to use a tool called ESP tool, and then you upload the firmware to the chip. Okay, so again, so the MicroPython has the concept of local file system, and when you run, you have a script called main.py, and when you reboot, it will run. And it also provides an interactive shell. So now, let's see how you can talk to this. Yeah, okay, just another word about this Pico Explorer board. It's just nice for prototyping and for learning. And again, it takes a lot of the pins that come from the microcontroller, from the Pico board, and it exports them to these controllers on the side, and also to the display, so you can show things interactively on this device. However, you might consider for your final project to buy the Pico board and solder it in, or actually, if you want something really small, you can just buy the chip and connect it directly. So, before I start the demos, let's talk about a nice Python editor called Tony. Like my son's dog. That's no connection. So it's a nice, simple editor for learners of Python. And what's nice about it in terms of the MicroPython, it actually comes with MicroPython integration. So let's look at Thony. Oh, that's not Thony. It crashed before together with everything else. So let's run it. Okay, so let's get rid of this at the moment. Yeah, so this is Thony. So what you can do here is you can specify your interpreter. So I'm saying here that I'm going to use the MicroPython interpreter, and I'm running it on the Raspberry Pi Pico. I also need to configure which port I'm running on, and on my Linux device it's T2Y ACM 0, and on every device is something else, depends on how the USB connects. So this is again, this is USB connection, and now what happened is after running this I get a shell. So this shell is running on the MicroPython device. So now I can do normal Python commands. I can do a os.listdir, and it will show me the files I have on the file system. So this is a file system, and Thony allows saving the programs you write onto the MicroPython file system. But let's try to do something interactively. Let's go back to the circuit, and instead of connecting this to a 3.3 volt, I'm connecting it to GP0, which is the port 0, the pin 0 of the chip. And now I can use some Python, import machine, and it can do my p is equal to machine.pin 0, that's my pin number, and I want this to be machine.pin.out. Okay, now I have configured a pin for output, and I can do value, and it will say that the value is 0. Okay, so now I can change the value to 1, and that turned on the LED. So now let's do a loop for I in range. Oops, sorry, let's do the first import time for I in range 10.
By the way, for everyone who hasn't programmed in Arduino, this is about 50 times faster than
it's much.
an Arduino upload.
Yeah, this is much nicer, and the fact you can have print statements and everything, you can test things much faster this way. So let's do let's do our pin p dot value 1 minus p dot value. Okay, time dot sleep. Okay, we wrote our first program, and we managed to get our LED to blink. So doing the same thing in Arduino is indeed quite a lot more rows of line you need to write.
So are any of these boards, do they have analog output, or they all?
Yes. Yeah, there's let's see, this says there should be something which is the ADC here is the analog. I don't remember if they're analog output or input, but it has both output and input. Of course, you can write your own bridges, and you can buy lots of extra hardware for doing that. Okay, so let's see what else I wanted to show. Yeah, so we did that. We actually managed to turn on the LED from a shell. Now, what's nice about these boards is that they come with extras. They have extended MicroPython. You can extend MicroPython yourself also if you want. If you necessarily have some time-critical code that you want to write, so you can actually create your own version of MicroPython. So you can do most of your program in Python and then just have the time-critical routines written in C++. So this company who made the Pico Explorer, they're called Pimoroni, they have added the module Pico Graphics. So if I run this code, let's copy this, and let's go to the and now let's start a new file. New, and let's copy the code in there. And now I can run this, and it now outputs something on the screen. So this works. This is really like Python programming, but you're working with a microcontroller. Yeah. So again, you have other MicroPython boards. You have the ESP 8266 and another one which I have lots of these at home. My whole house is filled of small microcontrollers. I have a very advanced system for the Shaon Shabbat, for the Shabbat clock, which turns everything on and off automatically. So I have one of these chips is sending out infrared commands for the air conditioner to turn on and off, and another one is pushing a button. I'll show you in a while how you can also use this with servo motors. And I also have one of these, which is the ESP32. What's nice about that one is it has Wi-Fi. So I actually have this connected in parallel to the power button on my computer, so I can send a command to turn on the computer remotely. As I said, these boards, they also can speak to other hardware. If you go into an electronics store and shop, most of these will speak one of these three protocols: UART, which is serial communications, and I2C and SPI. I don't know the difference between them, but these are somehow more lightweight protocols and fast speed protocols. For example, this display here is probably speaking SPI, I believe. Again, we can also use Wi-Fi. So let's see an example. We want to read the UART input. So UART is a serial communication, and I have actually programmed this already. So when this is connected to power and you press the button here, the wires here will output a message, and we'll try to catch this message by programming the Pimoroni board, the Pico Explorer, to catch this message. So let's copy this. Okay, and let's go to Tony. Oh, this is only I'm surprised it's I see this code is only reading one message, but let's try it anyhow. We can try to modify it. It says here, my instruction is that I should connect this. I should take the black one, black should go to ground. Let's remove these.
So you're trying to communicate between two different boards?
Yeah, two different devices. There's no connection between them. I'll speak UART between them. So black goes into ground, and white goes into GP0, and so. And I'm surprised actually that I don't need power for this. I probably do need power, so let's connect it to micro USB. Otherwise, it's not going to work without power. I can probably get the power from the. Let's take. It should work also if I take the power from the. I put too much. Let's again go to plan B.
The print goes to this editor, not the drive.
Yeah, print goes to the serial, to the shell, to this is it's called REPL, the read evaluate print loop, and this is the shell that you're working with. So let's get this. Yeah. Now this one has power. So now when I'm pressing, I'm actually running a small program there. So let's see if we can catch the messages.
Connected now. The black one.
Oh yeah, thanks. Yeah. Okay, so let's see if we can do this. Let's see if is that working? Oh well. Anyhow, it should work. Well, bugs happen. So let's go on. Move on to the next one.
You're supposed to display something on the
Yeah, this one is supposed to print the message which this device sends. It sends a message, and it's every time you press the button, it sends another message. But and I was supposed to catch this message, and for whatever reason, it's not working right now.
What is this small device again? This square one.
Yeah. So this is a this is the ESP32 inside. It's called M5 Stack Atom. It's a company that produce lots and lots of nice devices like this. So this is one of them, which is the simplest one. It just has a button, and here's another one with a display, and here's yet another one which also has an internal battery. So you can use this quite easily, and they also come with everything is documented here, so you can see exactly what pins you have connected and so on.
Just only like 2 pins from this.
Well, what I was trying to do, I was using this port and outputting serial information, the UART information. So it's also running MicroPython. So I wrote
It's also sort of Raspberry Pi.
Well, no, it depends what you mean by Raspberry Pi. Raspberry Pi is a company, and the Raspberry Pi, they produce the Raspberry Pi computer, which is a real computer. So this is the ESP32, which is inside of this, is also a microcontroller. It's very similar to the RP240. It's just a different company and has different advantages and disadvantages. So let's move on. Yeah, so let's see if next demo, let's see if we can get this to work. Let's connect the serial motor. So let's see if this works better.
Can I just briefly say something about communication protocols for people in the audience who don't know? So you mentioned several different communication protocols. The idea of communication protocols, I don't have a technical definition for it, but basically it's to make your life much easier when you're trying to communicate some more complicated piece of information. Like if you're trying to all these boards, they just have like, it's mostly relying on digital input and output, right? So you can send like a bunch of ones and zeros, and the board should somehow know to translate those ones and zeros into an analog signal or a bunch of bits or moving some kind of a servo to a certain angle. Like you can do that from scratch, but it's extremely complicated and you're not going to do a good job at it. So that's why there are all these libraries in place that you can import them, and then you tell them, okay, read this channel. It's some kind of a digital channel, and that channel gets inputs, and those libraries know how to translate that bunch of ones and zeros that come very, very quickly into some kind of like I mentioned, an angle of a servo motor or a picture or text or whatever. Is that accurate?
Yeah, absolutely. If all the information you want to send is binary, on or off, you can use a single pin to indicate that.
You don't need a lot.
You don't need a lot, but if you want to send more complicated information, then these different protocols will do that, and they will usually do that on a single wire. So you don't need, like once in good old days there was something called a parallel port, which was a big thick port where you had all the pins in parallel to make up a byte. So the serial communication allows you to send the bytes one by one according to a certain scheme, which is the definition of the protocol. So next demo. Let's hope this one works better. I have now connected a servo motor, and I've connected it again according to this configuration. And the way servo motors work is that they have something called a signal, which is sent at a speed about 50 kilohertz. And according to the duty cycle of the signals, the servo motor will rotate. So let's try that with this program. So MicroPython already comes with a module called servo, which allows communicating with the servo motor. Let's see there, and didn't work.
Does it have like output current strong enough to drive motor?
The strength depends on lots of things, whether the card is driven by micro USB or USB Type C, and so this card is using micro USB, and there are obviously current limits, but so everything you have to check whether you have enough power. But obviously you can use transistors and relays and whatever you need to you can turn on the power plant if you have enough steps in the middle. So as long as you have the binary signal, you can always amplify it and do whatever you want with it.
Probably should be in specs of the card.
Yeah, certainly, right. Yeah, no, maximum. The worst thing you can do is to burn the card and buy another one for 25 shekels. So, and let's see if this works. Let's try to run this. So this worked, surprisingly. So now our MicroPython program is running this as a server program. So actually, we can try what happens if I now save this. Let's save this as main.py. So here, when you do save, Tony will ask you where you want to save your code. So let's turn it onto Raspberry Pi Pico, and if I now call it main.py. Okay, so now if I do import os.list there.
That will run continuously.
Pardon?
It will run continuously.
Will run right now. As I wrote the program, it will run once, so like for 10 cycles. So let's reboot. Okay, I just do press Ctrl D, it will reboot, and it's now running the main PY program. So the same thing. If I now disconnect this thing from power, let's disconnect this from power.
Looks the same on Windows?
Yeah, totally it's the same on Windows. And now it's got power and it's running the main.py program. Let's try another communication protocol. I have something here which is another device. It's a LED panel, has 64 LEDs on it, and this is called the protocol for speaking to these is called NeoPixel, and it also MicroPython comes with this integrated as well. So let's try to connect this and turn on the LEDs. Let's see if I'm missing a yeah, this brown goes to 3.3, and the white goes to ground, and then I need another one. Somehow I lost. Let's take this one. Go to GP0, so it's orange instead of green. Okay. Let's see if we can turn this on. Let's see if I can hold it in place also. It's kind of crowded in here. Okay, we see something at least. So let's try this program. Again, it's standard Python. You just need to know the modules and the connections. So let's go to Tony. And so with Tony, with NeoPixels, all panels have different amounts of LEDs. So this one here has 64. Actually, this M5 Atom, it has 1 NeoPixel as well in the middle, actually in the button. So you can, so for example, when I write something which connects to Wi-Fi, so while disconnecting, it's red, and then once the connection is established, I change the color to blue. So let's run this. Oh, yeah, I have to reconnect it again because I disconnected it before. Configure interpreter. Okay, let's see. It's not working.
Maybe it's just an old message, no?
Don't think so. I was trying again. It could be that this thing is shorting the board somehow. Let's hope not. Let's disconnect it and see if I can. Let's stop. Yeah, now it's up again. So let's try again. This goes to 3.3, and this goes to ground. Okay, let's see if I'm alive. Yeah, I'm alive. So let's try to run this. Let's put this on here somehow. Yeah, so it's a bit difficult to see. The camera is it's totally saturated. I'm actually using, this is actually running right now at level 1 out of 255. So this panel can give quite a lot of light. So the red one is 255, and the other ones are at the minimum level. Actually 10 out of 255. These are nice panels. I have one of these at home to show me the clock on the wall. So I'm also using it sometimes to get illumination for a web conference, for Zoom talks. So yeah. So this is a complicated, relatively complicated protocol, but this NeoPixel, it makes it trivial to use this types of panels. And what's nice about it physically is that these can be changed. So if you look at the panel itself, so right now this is the input, and here you also have something which is not connected right now, but this connects to another panel. So if you connect 2 of them in series, you get a panel which is a 128, and you can go on and really you can get thousands of pixels this way. So you can make a whole full display. They're using these for light shows and huge wall displays. So let's see what more I want to speak about, and then I think we're off.
Are
Yeah.
these bulbs strong enough? I don't know if it's the right word for image recognition and stuff to do like.
It depends, like everything else. There are boards that have integrated image processing units inside of them, but it's with the neural networks and so on. It really depends what you want to look for and how complex the image processing
like
is.
These two, the ESP32 and the P.
Yeah, right. If you think about it, these processors are running 150 megahertz, and when I started, my first computer was running 8 megahertz, and so these are 133 gigahertz, and the first computer was something like 1 megahertz. So it's all relative. It really depends on what you want to do.
Okay.
We could make an example, but because of lack of time, I'm not going to run this. But you can easily connect to Wi-Fi, and this you can do, for example, on the D1 Mini, which is somewhere around here. Let's see, just show the card.
To connect and do what?
Well, for example, you can connect and then you can run a web server on the chip.
Like, okay, it's just the connection and then you add something.
Right, and then once you have the connection, then you can run a web server, and then you can communicate with the chip. For example, if you want to send a message to open a gate to feed the rabbits that you're then you can do it by remote. So you can do anything that the cards can do. You can do anything the cards can do by remote.
So this, like, you upload the Wi-Fi connection file. I don't know how to say it correctly. The .py.
Yeah. So
and then you have a separate file for the server, let's say, or it will be all in one.
It's typical Python, and
I'm not familiar with Python.
Okay, so right, so the way it works is that when you boot the chip, it runs the main.py, and Python can do import, so it can import whatever it wants.
So I call for another.
Right. So or you can quite easily write the web server yourself. It's not that complicated to write an HTTP server. But again, there are also other protocols. I'll mention that in a while. But just this is shows you how easy it is to connect to another network. You just need to import the network module, and then you do a few calls, and then you're connected to Wi-Fi, and then it's two-way communication like any Wi-Fi. So we can I'm showing this again. So this is an example of using the chip as a client, so we can connect to an external service. So we're getting the JSON file of all the astronauts in space by the opennotify.org, and this can run on the chip. And so there are various ways that you can communicate both from the chip and to the chip. And so one of the most common protocols that was developed for IoT is the Internet of Things, is a protocol called MQTT. MQTT is based on the idea that you have a broker in the middle, and then you can subscribe to messages from this broker.
Like a server for
right.
a small device.
Yeah. So the advantage of using something like MQTT is that you will not need to know the IP address of the device itself, because if your house is full of lots of devices, then you need to know the IP of each of them if you want to communicate with them by a web server. But if you're using something like MQTT, then the device itself is connecting to the broker. I have a broker like that running on my Raspberry Pi at home, and then I can just send messages to the broker, and these will be forwarded to the device itself. So this is a nice way of having tens or hundreds of different devices.
So I could do it yourself much cheaper Google Home.
Yeah, right.
I know there's like the Matter protocol or something, or it's something different entirely.
I'm not familiar with the Matter protocol, but I guess it's something similar. Yeah, and there's the other ways as well. You can speak also. There's something called Web REPL, so you can actually speak the REPL protocol by HTTP, and all these commands that right now I sent manually. You can also send them over the Web REPL protocol. And you can also, another thing I've done is writing a Telegram client. Telegram is nice because you can write programs for the interaction very easily. So you can write clients that run Telegram protocol on the chip itself. Yeah, I guess we're out of time. Let's see what else I had here. Okay. So let's finish. Even though there are lots of things, you can see have a whole course of this, obviously. So, any questions? Yeah. So, again, thank you, and I'm sorry for the problems that occurred in the beginning. Eventually, it's worked. So let's stop the recording, and then you can ask the question.